Here at example 3, we've got f of x is equal to 3 minus x. We're asked to explain why f satisfies the conditions for the mean value theorem for definite integrals on the interval -1 to 3. Well, the only condition we need to satisfy for the mean value theorem for definite integrals is that the function has to be continuous, which it is. So f is continuous everywhere, in particular on the interval -1, 3, so the mean value theorem applies. Now we're asked to find all values c guaranteed by the mean value theorem for definite integrals. So the mean value theorem for definite integrals says at some point we can find some value c in the interval -1 to 3, so that f of c is 1 over b minus a integral a to b f of x dx. Remember, this is another name for, or this is how we calculate the average value of the function. So here we go. Well, first off, we got to integrate. So we're going to integrate from -1 to 3, f of x, 3 minus x dx. We can evaluate this using the fundamental theorem of calculus. An antiderivative for 3 is 3x, minus an antiderivative for x is 1/2 x squared. Going to evaluate this from x equals -1 to x equals 3. We're going to toss in the top limit, the 3. 3 times a 3 minus 1/2, 3 squared. Minus, toss in the bottom limit, 3 times a -1 minus a 1/2 times a -1 squared. And now we go through the arithmetic here. Let's see what we get. We get a 9 minus a 9/2. So go to the next slide, I guess. So I've got 9 minus 9/2 is 9/2 minus, and here we've got a -3 minus -3 minus a 1/2, because that -1 is going to get squared. So I have a -3 minus a 1/2. So that would be a -6/2 minus a 1/2. So that'd be a -7/2. So minus a -7/2 actually means we're going to be doing what? Adding. So that's going to be 16/2, which is 8. And so my average value is going to be 1 over b minus a integral a to b f of x dx. So that's going to be 8 over 4, which is 2. So I need to figure out a place where the f of c is equal to 2. So my f of x, once again, that's the 3 minus x. So I would need 3 minus c to be 2. In other words, c would be 1. Okay, so the guarantee is when c equals 1, f of 1 should equal the average value. And sure enough, if I plug 1 into my function, 3 minus 1, I get 2, which is the average value. Check your answer geometrically. So to check our answer geometrically, we need to fire up a graph. And we're going to use Desmos here. So we have a nice accurate graph. So we're going to type our function f of x equals, and the function is 3 minus x, but we only care about it on the interval from -1 to 3. So -1 less than or equal to x less than or equal to 3 of 3 minus x. The average value we're giving is y equals 2. So we're going to put y equals 2 in there. Once again, just between -1 and 3. So there it is. If this really and truly is the average or the middle value, what should be true is that if I look at the area from the graph to the line, above that should equal the area of the graph up to the line from below. So let's check this out. If I look here, I can see that that's 2 units this way. And we know that this value is happening at 1. So this is -1. So we've got 2 units this way. And then sure enough, I've got 2 units here and then 2 units here. So the area 1 is 1/2 2 times 2, which is 2 units squared. Area 2 is 1/2 2 times 2. That's also 2 units squared. So the area of the function which is above the average value matches the area of the function which is below that value. Or another way to think about that, once again, is if I take the integral from -1 to 3 of my function minus the average value, I'm going to get 0, which tells you that this really and truly is the middle function value, the middle y value on that interval. So that'll do it for example 3.